But okay, so hi, my name is Diego Tejada. I'm representing my friend Ni. We are colleagues in TNO. So I'm going to show you these two projects that we are working on energy system models. So yeah, so first we will start with TulipaEnergy. Okay, let's give it a start. So we work at TNO. TNO, it's like Syntef, so it saved me a lot. It's the same type of company that is just a research center that works closely to apply research, so universities, but also companies. So we have several areas that there is research, but especially we basically are focused on the team that I work with. It's in energy and material transition, so energy models. So yeah, and it's based in the Netherlands. Okay. So yeah, another energy system model. Sorry if some of the models that are here are not in the in the list. I apologize in advance, but yeah, there are a lot of. I think yeah, Jose is there. It's yeah, powersystem.jl and Gen X. It's yeah, okay, but basically yeah, another one. I will try to show you what we are trying to do, kind of yeah, differently, but in the end, I guess we all are aiming for the same stuff. So the challenge is basically also something that is quite known. Most of us have been facing this kind of stuff, is that we have the problem of integrating more renewables. We have also large-scale problems that there are several years. You have a really wide area that you need to cover, so different countries, different carriers, and so it used to be electricity, now it needs to be electricity, gas, heat, everything, so hydrogen, so yeah, it's everything. So once you improve your model, then something comes up, and then your model again increase in size. So you need to start all the time improving the efficiency on how you build the model and how you work with all this stuff. So that's the challenge. I guess we are kind of relate to that. So what is TulipaEnergy? I joined TNO two years ago. I'm coming from more like a GAMS background, but then I just 3 years ago when I moved to the Netherlands to work in this project, TNO decided TNO was working on AIMS, but then and again, as Syntef, open source, let's go move to a more open code. So we decided to start working, and then what we should choose. We went for Julia and Jump. So we decided to start a new model for energy, investment and operation. We also, we defined the energy asset as one of our key components. And the focus of this project is, used to be very compact and very efficient formulations. So we can basically represent these models in a very efficient way and being for use to everybody. So we started from scratch. And Tulipa is just because, yeah, it's from the Netherlands. It's quite the flower, so we started from there. Okay. So this is the team. So we have from TNO, Germán Morales, myself, Lauren, Ni1, my colleague that was going to present, but he couldn't make it, also Vester. But it's not only TNO. This is a project that we have some funding, and we are working with the TU Delft University. So we have a postdoc and 2 PhD students. And also we have from Utrecht University, from the Netherlands E-Science Center, we have Abel. I think some of you might know him. He collaborates a lot, and is really, really, really good at Julia and Jump. So he had helped us a lot. And Subhaju is the person that is helping us with a lot of the data pipeline. So that's basically the team that is working on this. Okay, so I will try to go through some of the innovations that we are trying to implement in the energy modeling in general, but especially in Tulipa. And yeah, and later I will share some experience that we have encountered under this journey. So one thing that it's maybe interesting is that since we want to reduce these big problems, normally people rely on clustering, so you have a large time scale, time series that is, for example, your demand or your renewables, and then you reduce that to representative periods or representative days, and then you rely on clustering. So what we are doing with one of the postdocs is that, with the postdoc with Greg in this case, is this new way of trying to clustering. Instead of having the centroids, we are trying to get a whole clustering, trying to get the representatives as these, let's say, extreme representatives that can give a better representation with less representatives. So this is something that we are working on. It's working well. We are being testing it, and yeah, it's a new way to cluster the information and get the representative periods. So if you are interested, there is more information of that. That's one of the things that we are working on. Yeah, this is the other one. And I would like to say that I really like when the Sintef mentioned the time structure. We want to take a look to that, because this is kind of the same idea. What we are trying to do here is basically fully flexible temporal resolution. So the use case of this is, for example, if you have an European case study, normally in our case, we are interested in solve the Netherlands in highly detail, but for example, the neighbors maybe just in 2 hours, and that will reduce the computational, the computational needs, and then you can reduce again to have 3 hours and 4 hours, and then you can kind of reduce the complexity of the problem, but still you keep the fidelity that you need or what you want in what is your point of interest. What we have found is this, for example, kind of thing that, of course, if you solve everything hourly, it takes a lot of time because it's the whole of Europe. But here you can basically get with less time. Here will be the fully flexible temporal resolution. Here's 2 hours, 3 hours, 4 hours, everything with 5 hours. So all 1 hour, all 2 hours, all 3 hours, all 4 hours. And here is this, let's say, flexible temporal resolution. You can get a really nice less time, and the error is even less than having everything in 2 hours. Okay, cool. Great. So more things. We have been working in this graph-based system representation, which resembles also the component-based that Sintef is working on, just trying to have some graph representation that allow us to have more generic components that can be connected, and that help us to reduce in some occasions, can reduce the number of, reduce the problem and get the same solution. Yeah, okay, I will speed up a bit. So with Julia and Jump, we have these packages. This is the TulipaEnergy model, which is the building and running the optimization model. The clustering, which is the one with the first one that I show, and the I/O, which is the data manipulation that we are working on it. These packages basically rely on these other ones, so data frames, Jump, and Graph. And we have, for the clustering, we rely on clustering and distances.jl. For Tulipa.io, we are working now with DocDB, which is quite interesting. Yeah, and also these are the other things that we are using that we really like from Julia, which is, of course, we have the documenter, HICE, we have representative from HICE, so great. And this is a nice one, developed from, I recommend it to everybody that is deploying a package, Bestie template. It's a template, it's from Nabel. It's template that has everything that you need for develop a package. So the CIs, everything is in place there, and you can apply it to existing projects. So it's really cool to deployment any package. Okay, so this is more or less what we try to achieve. It was we are in development. We started last year. We are this year also developing some core features. And next year, the idea is to go for more stuff. Okay. So this is actually what I wanted to focus on a little bit, is that, yeah, Jose Daniel said, okay, what is big? Okay, this is not that big, but it is still big. It's 1 million variables and 2.5 million because it's a small sample. But we started since we were newbies, we started with initial code that was really bad. It was taking so long, and we optimized the code, and then we got a reduce in the how to build the model. And how did we achieve that? So first, we tried the basic naive jump, let's say, style. And then we used data frames to linearize the indices. And here I would like to thank, because it's actually, we asked in the discourse, and yeah, people reply. We got a lot of ideas, and that speed up was thanks to the data frames implementation that we did. So we really appreciate the community of JUMP. It's really useful to have these kind of things in there. So good things: speed, efficiency, straightforward syntax using JUMP, the great community support that you can use. Of course, it's in the UL environment, so you can use a lot of things that are surrounding, and yeah, you can easily connect everything. It's friendly for both, for researchers and also for software engineers. It's also really good that they can teach us a lot. Room for improvement, let's say, yeah, of course, to do the data frame stuff, we need to go a little bit step further, but I guess, yeah, if you want to really speed up, you need to know more. Yeah, and this is also interesting. I was going to ask about this. Gather, update, solve, scatter is something that is in GAMS, but it's basically the parameter op interface. So I'm really happy to be here, because now I know that I need to explore this parameter op interface.jl. So maybe this is no longer here. I need just to start exploring that. And we are working on this. It's near optimal alternatives. It's something that is, we are working, it's something that we might develop a little bit further, and maybe later we are doing it generic, so just could be later an extension from JUMP, is that you can explore optimal solutions near your optimal. So you can say, I want to have 1% error, and I want to have all alternative solutions with 1% error that are the most different from the first one. So that's it. If you want to check out, that's where is the repo. Thanks.